right, welcome everybody. We're going to be giving you an overview of Compass North and their pilot data tracking app. So a quick overview of the company. Compass North is an aircraft management software platform designed to streamline the business side of private, business, and corporate aviation. We want to do this by taking the relevant information that pilots have when they're logging flights and going through their day-to-day activities, such as verifying system checks, registrations, all that data to make sure the aircraft is ready to go. And then we want to make sure that we provide them with a more fast and efficient way to keep this information in one place and make their job easier. So how do we solve this? We're going to make an application that can be used online, offline, something that can store information, track it, and be able to provide it again quickly on the go when the pilot needs it. We want to ensure that data is up to date and make sure we can essentially make this as easy and efficient for the pilot as possible.
We'll run through some introductions here. For our stakeholders, we have Don and Merritt Kratzel, who make up Compass North and give us the specifications for the project. Then we have our project manager, Melanie Kugler-Wright, which she was unfortunately not able to do full project manager duties on this project due to scheduling conflicts. So our tribe lead, Jeffrey Falkenberg, took over some of those responsibilities while she did some of the asynchronous things still. And then our industry coach was Chris Hilton, the principal engineer at Allplan. And we joked that he was also our honorary legal expert because we kept coming to him with legal questions about software. Then for the student team, we have Adam Dahlman, the squad lead and dev manager, handled more of the bureaucratic side of senior design and was the primary point of contact for sponsors. Myself, the product manager, Jake Nichols, generally just focusing on making sure code was quality and that we were hitting requirements correctly. And then for those that are at the table, not in here, we have Dylan Kramer, a developer, Alex Canfield, process specialist, Gupal Kadali, also developer, and Sarah Louderman, developer. So we'll go over for the problem and opportunity what the application needs to do and how we solve this more technically. At a high level, it needs to allow logging trips and legs of those trips for aircraft flights. We also track expenses that any pilot would take on a trip, such as fuel or hotel or anything else. And then, as well as aircraft checks, we obviously log things about the aircraft itself and anything that was done to it through the course of the flight. For some of those checks, we have GPS database checks, making sure that the database that's on the aircraft is up to date before they leave. VOR checks, making sure the VOR receiver is calibrated within the last 30 days. And then making sure the plane is actually registered with the FAA and legal to fly. The high-level goal is to automate as much of the process as possible, basically so that pilots don't have to enter all this information themselves, and they can focus on the fun part, which is flying. Probably the biggest challenge is that it needs to work mid-flight, so it needs to work offline, so we had to introduce caching to make that work. And then we also were made aware of a releasable FAA database which has information based on tail numbers of aircrafts. So we integrated that into the application to try to help autofill things faster. So from the tech side, we used a progressive web application, or PWA, made in React and TypeScript. So that allows it to work seamlessly both online and offline. It's something that works at a website or it can be downloaded to the user's device. For some specifics, we dealt a lot with UTC date time fields, which is essentially pilots put their information in UTC, and we want to display it back to them that way, rather than worrying about converting between local and UTC. It sounds simple, but it can be difficult with something like Node, where it constantly wants things to be in local time. And then we use the PostgreSQL database to store all of our data as well. This semester, we introduced a new Amazon Web Service Lambda function, which goes out, fetches the database from the FAA, parses what we care about, and then puts it into our own database for our use. Then as well, it is a serverless AWS Lambda function that works as our backend and essentially is the API to put things between the server, or between the front end and the database for users. And then kind of the technical details about how it works online and offline is that we have a cache on the local storage of the user's device, which when they're online, it fetches as much data as it can or that's relevant. And when they're offline, we store it to the cache, pretend that that is what the server knows about, and say, we're going to optimistically say this is going to work. And then once we come online, we send it all to the server, and if everything's good, it's seamless and everything looks as it should, as what the updates they did while they were offline. So I'll pass it back to Adam for the product solution.
So looking at the solution, we have a screenshot to the right showing a little snippet of the application. But what are some other things that we actually did and add to the application to help this app actually work as smoothly as we want it to? One, we added some utilities so that now the pilots can more efficiently do their job. One of which was crew tracking and passenger manifests so that we know pilots who's flying, passengers that are flying. In addition to that, some of the things Jake mentioned, like expense tracking. We also added time tracking in hobs and TAC, which are two ways that airplanes can track time. We added some other stuff like VOR checks and GPS checks to make sure that the pilots know that their stuff is up to date. And then logbooks, because if you want to have this information on paper, we still want to be able to give you the information so that you can do that, so you can just print it out. These essentially can help the pilot in a few ways. One, we are still going to keep it all online in the same place that everything is kept. And two, using some of the other features we've implemented, stuff like the crew and passenger manifest, we calculate weight from that so we can determine the total weight of the aircraft, which can help the pilot determine whether we're approaching the maximum takeoff weight. And some other stuff like that is just supposed to help the pilot be able to streamline the process. As well, Jake mentioned that we had to do some caching. We wanted this app to work completely online and offline, which meant technically using caching, which means if the user does something when they're all the way up in the air, it needs to work just like if they were on the ground completely connected to Wi-Fi. I talked about some weight estimation. We also used auto-population and data persistence, which basically means if the users entered data at one place earlier in the process, we don't want to make them do that again. It's unnecessary, a little redundant, and it takes time. So we streamlined that anywhere we can. We use that data, pre-populate it for them. We also use the FAA data integration so that instead of having to create an aircraft, enter all that information, tail number, make, model, as we have on the picture up there, we do it automatically. So you click that find button, we finish out as much as we can right there. Another thing we added was manager level conditional viewing, which means essentially managers have special privileges that the pilots do not, and those people are going to be responsible for taking care of some of the aircraft stuff. Looking at the value and highlights, essentially what did our team add to this application this year? This is already existing, so we want to know how did it get better. We took this project from a team last year, and some of the most important stuff we added was caching. Obviously, if this app doesn't work well or at all offline, you're not going to really be able to use it, since this is an aircraft app. You got to be able to use it online, or in the air, excuse me. Some of the other utilities, just the tracking, registration data, that makes things a lot easier and all in the same place, that data persistence, FAA integration, and then the beginning of role-based authorization. Some of the highlights, this was a really interesting project, and we worked with a lot of new technologies, some of which were React, caching, making sure everything works offline, and the really popular AWS, which is Amazon Web Services, and then finally PostgreSQL, which is the backend for this. Those are some of the hard skills that we got from this, but we also learned some more soft skills. With some of the soft skills, I think it was really important working on an application which personally I and a lot of the team didn't really know much about. So this application was oriented towards pilots. So a lot of the lingo and jargon we weren't really familiar with, and we needed to be able to design an app that made sense to pilots, but didn't necessarily make all the much sense to us. So we had to learn what pilots knew, even though we don't have a lot of that information, stuff like what the pilots have to go through when they're starting, when they're finishing, and when they're on the runway, and we had to kind of learn what pilots are thinking. Because if we understand that, we're going to be able to make an app better oriented to pilots, even though we don't have any on our team. So as far as soft skills go, it really helped us kind of broaden our horizons and be able to think outside the box to try to make a solution to an application which we don't have really any personal experience with, since none of us are pilots. I think that was one of the biggest parts of the application that really gave us value going forward in our careers and lives. And then, of course, again, some of the other hard skills, such as working with optimistic updating, progressive web applications, which are pretty popular, and other various software. So thank you all for coming, and I also wanted to thank the sponsors. Dawn, I know Merrick isn't here. We have something for you, so if you could come up at this time.